Hi everybody, welcome back. Today I will explain how the change in pressure can affect the equilibrium state of a reaction. As we know, any reaction at equilibrium, well, if if affected by a certain stress, it will favor the direction that will relieve this stress or oppose this stress. And we already explained how concentration and temperature can affect the equilibrium state. And to talk about the pressure, to explain how pressure can affect the equilibrium state of a reaction, we need to know that this pressure is for gas states. And we need to know how pressure is exerted in gas state. The pressure actually comes from the collision between the gas particles and the walls of the container, which means that there are some factors that can increase that pressure. Like if the number of particles increases, more collisions will take place, which means higher pressure will be exerted. Lower number of particles will exert less pressure because there are less collisions. Also, if we decrease the size of the container, more collisions will take place, or the collision will take place faster, which means that will be more pressure. Anyway, if we have a reaction at equilibrium, this reaction is at equilibrium, and they are in gas state, in the gas phase. At certain pressure, the equilibrium is established. If the pressure is corrupted or interrupted by increasing or decreasing, if the pressure is increased, the reaction will favor the direction which leads to a decrease in that increased pressure. While if the pressure is decreased, the reaction will favor the direction where there will be more pressure to relieve or to oppose the decrease in the pressure. When the pressure is maintained again, the equilibrium state will be re-established again. Okay, but let's see it in details. Increasing the pressure, if the pressure is increased, so we know that the reaction will favor the direction that reduce this increased pressure. And usually, how to know which direction is favored? Find the direction with the fewer number of moles of gas. Because, as you know, less number of moles means less collisions and less pressure. So the reaction will favor the direction with fewer number of moles until the increased pressure is relieved. While if the pressure is decreased, now we need to maintain to re-establish the original pressure. We need to increase the pressure. So the favored direction is the direction that exert more pressure, which is the direction with more moles. So if we take into account, if we, for example, we have a reaction like CO2 gas decomposes into CO and O2. And both are gases. This at equilibrium. Usually use a balanced equation to know which direction is favored. In that reaction, we have 2 moles of reactant and 3 moles of product, 2 moles of CO, carbon monoxide, and 1 mole of oxygen. If the pressure is increased, it means the reaction will favor the direction of fewer number of moles, this direction. So the reverse direction will be favored until the pressure is maintained and the equilibrium will be re-established again. While if the pressure is decreased, the reaction will favor the direction where this decreased pressure is increased, so with more number of moles. So in that case, so the forward reaction is favored. And usually, change is in equilibrium is a temporary state until the original state is maintained and the equilibrium it will be re-established again. This is a quick idea of how pressure and can affect equilibrium. What are other factors? We have other factors that can affect a reaction, but they have no effect on the equilibrium of the reaction, like using an inert chemical or a catalyst. Both of these won't affect the equilibrium state of the reaction, so there will be no shift in equilibrium. The inert chemical are not reactive, so they will not participate in the reaction and they won't interfere in the reaction, so they will have no effect on the equilibrium. For the catalyst is a substance that can speed up the reaction, but it won't interfere in the reaction. It won't be consumed during the reaction, because at the end of the reaction, the catalyst will be retrieved to its original state again. So it won't affect the equilibrium. So we have 2 factors that will not affect the equilibrium state, the inert chemical and the catalyst, because they will not interfere with the reaction and they will not cause any change in the reaction rate, whether the reverse or the forward reaction. Now we have got a big idea about Chatelier principle and its examples, and what are the factors that can affect the reaction equilibrium, and what are the factors that have no effect on the reaction rate. If you have any question, write it in the comments down below. If you need a specific topic to be explained, please don't hesitate to write it down below. Thank you guys. If you don't subscribe, if you like this video, please subscribe to help grow my channel. Thank you and bye bye.